millimeter of wheel travel, how much the shock absorber travels. Okay, so all of you may be knowing it's a simple lever arm. Suppose if the shock absorber is inside, then the motion ratio is less. Motion ratio less அப்படின்னா இப்போ வீல் வந்து ஒரு 1 millimeter மூவ் ஆகுது இல்லை 100 millimeter மூவ் ஆகுது அப்படின்னா shock absorber will move very less, 40 millimeter or 50 millimeter, right? So the effectiveness of the shock absorber is compromised whenever the shock absorber is packaged inboard. Okay, in the car your wheel track is fixed. இப்போ நம்ம Thar ROXX எடுத்துட்டோம் அப்படின்னா wheel track வந்து 1580 millimeter வந்து wheel track. That is the distance between the center line of the two tires in the front view. That is called as wheel track. இப்போ உங்களுக்கு wheel track fixed, tire width fixed. Okay, so ரெண்டு டயருக்கு நடுவுல நீங்க வந்து ஷாக் அப்சர்வர் பேக்கேஜ் பண்ணீங்க அப்படின்னா உங்களுக்கு ஃப்ரேமுக்கு வந்து இடம் இருக்காது. ஓகே, ஸோ வழக்கமா எல்லாரும் என்ன பண்ணுவாங்க அப்படின்னா ஃப்ரேமோட லாங் மெம்பரை வந்து டயருக்கு பக்கத்துல போட்டுட்டு ஷாக் அப்சர்வர் உள்ள போடுவாங்க. அப்படிதான் வந்து நம்மளும் பண்ணிக்கிட்டு இருந்தோம். ஓகே, ஸ்கார்பியோ என்லயும் சரி, நம்மளோட 3G ஆர்கிடெக்சர் அப்படிதான் இருந்துச்சு. இட் இஸ் நாட் பேட். ஓகே, பட் இட் இஸ் கிவிங் யூ சர்டன் லெவல் ஆஃப் ஷாக் அப்சர்வர் எஃபெக்டிவ்னஸ். இப்போ நம்ம என்ன பண்ணிருக்கோம் அப்படின்னா டயர் எங்க முடியுதோ அங்க வந்து ஷாக் அப்சர்வரை போட்டுட்டு ஃப்ரேமை வந்து பெண்ட் பண்ணி உள்ள கொண்டு வந்து எடுத்திருப்போம். அது வந்து கிராங்க்டு ரியர் லாங் மெம்பர்னு சொல்லுவோம் நம்ம. ஸோ இதனால என்ன ஆகுது அப்படின்னா ஃபார் 1 millimeter of wheel travel, your shock absorber now will travel 0.9 or 0.85. That is called as motion ratio. So the motion ratio, when it is increasing, the effectiveness of the shock absorber will be better. அதனால என்ன பெனிஃபிட், கஸ்டமருக்கு என்ன பெனிஃபிட் பார்த்தீங்க அப்படின்னா இப்போ earlier வந்து நான் வந்து இப்போ ரோல் கண்ட்ரோல் பண்றதுக்கு வந்து எனக்கு வந்து ஷாக் அப்சர்வர்ல இவ்வளவு டேம்பிங் ஃபோர்ஸ் வேணும் அப்படின்னா இஃப் ஐ புட் த ஷாக் அப்சர்வர் அவுட் போர்ட் ஐ வில் நீட் லெஸ் டேம்பிங் ஃபோர்ஸ். கரெக்ட், ஏன்னா வந்து என்னோட ஷாக் அப்சர்வர் வந்து வெளியே இருக்கு. ஸோ நான் ஐ கேன் கண்ட்ரோல் த ரோல் இன் அ மச் பெட்டர் வே ஈவன் வித் லெஸ்ஸர் டேம்பிங் ஃபோர்ஸ். ஸோ நவ் இஃப் மை டேம்பிங் ஃபோர்ஸ் இஸ் லெஸ் ஐ வில் கெட் அ பெனிஃபிட் இன் த ரைடு கம்ஃபர்ட். when I'm in the straight ahead normal drive, then I get a benefit. So you get benefit both also in the roll, right? When you're taking high speed cornering, when the vehicle is trying to roll, because shock absorber is outboard, right? Plus you also get a benefit in the ride comfort. That is how it is.
Okay, sir. And I have another question, sir.
Okay, I have limited time. Can you give opportunity to others also? Maybe you can send me through mail. I will try to respond. You can give the question to Mr. Wales. Just because no, I have to rush to another meeting. Maybe another couple of questions I can take.
Thank you,
Tamichalan. Very good question. I'm happy that you captured that point very well.
Yeah, from the front, you. Yes. Introduce yourself and quickly your question, please.
Hello, sir. My name is Sanjeev Sridhar and I'm from CEG Anna University. And my question to you will be, the wheelbase has been increased compared to Thar 3-door, and how does this particular increase in wheelbase only, the track width and ground clearance has not been increased much significantly as compared to the wheelbase. So how does this parameter affect the whole vehicle dynamics, including pitch, roll, and yaw body motions of the vehicle?
Okay, very good question, Sanjeev. 3-door Tharoda wheelbase பார்த்தீங்கன்னா 2450. Okay, Thar ROXX பார்த்தீங்கன்னா 2850. 400 millimeter வந்து wheel.
Welcome to the lobby.
It's a very laid back car. நம்ம இந்த 2850 dimension choose பண்ணதுக்கு மெயின் காரணம் என்னன்னா that is the right sweet spot which will give you I would say a very reasonable ingress egress for getting into the car and getting out of the car. Plus it will not affect the proportion of the car from the side view. அதாவது இந்த height and width and length ஒரு ப்ரொபோர்ஷன் இருந்தால் தான் வந்து உங்களுக்கு பார்க்கறதுக்கு வந்து கார் ரொம்ப அப்பீலிங்காக இருக்கும். அது ரொம்ப இப்போ நீங்க இப்போ ரேங்க்லர் பார்த்தீங்கன்னா வந்து மோர் தென் 3000 millimeter wheel base பார்க்கறது வந்து ஒரு கார் ரொம்ப லாங்காக இருக்கிற மாதிரி இருக்கும். கார் வில் நாட் ஃபீல் அஜைல், கார் வில் நாட் ஃபீல் பவர்ஃபுல் அண்ட் ரெடி டு கோ, அந்த மாதிரி வந்து ஒரு ஃபீலிங் இருக்காது. அந்த ஃபீலிங் கொண்டு வரதுக்கு வந்து பார்த்தீங்கன்னா the sweet spot is 2850 that we have arrived after almost 6 months of internal deliberations. Now coming to your question, the moment you are increasing the wheelbase, what happens is along with the wheelbase, your rear axle, your rear tires, wheels, brake disc, calipers, all of them go back, correct? So in a way, what you are doing, center of gravity of the car, you are pulling towards the rear of the car. The rear axle mass is more compared to when the wheelbase was 2450. So as you go further and further towards the rear axle is pulling the CG towards the rear. That is putting a lot of challenges on the yaw control. So I will say for the pitch, it is better because longer wheelbase means it will resist the pitching. For the roll, it is almost neutral, but for the yaw, which is extremely important because yaw is the one. So yaw is nothing but rotation of the vehicle about the z-axis, right? So now if the yaw is not controlled, the vehicle will lose the direction and you will go and end up in an accident. The yaw control becomes extremely challenging when the wheelbase is increased, right? That is why I explained all those things, how we try to bring the understeer. So even when I give a sudden input, the vehicle responds in a more calibrated, in a more matured way, so that you are able to have a confidence at high speeds, right? So to sum it up, the wheelbase increase was a careful trade-off to have very good ingress egress versus a very good proportion. The wheelbase increase is good for pitch, almost neutral for the roll, but very dangerous for the yaw because the CG is moving back. And to overcome that only, we had to do a lot of work to bring the understeer. In fact, even for the pitch, sometimes it was becoming really uncontrollable because when the vehicle in the normal condition, it was okay. But when the vehicle was going through a speed breaker, the rear was throwing up since the wheelbase was very high. That is why we had to put that hydraulic rebound stopper. In fact, even for the pitch, it was giving a lot of challenges.
Thank you, sir.
Yeah. Thanks, Sanjeev. Yeah.
Sir, you
Maybe
told
this is the
that
last question. Yeah.
Sir.
Yeah, tell me your
sorry,
thing.
this will be the last question. Please go ahead.
Sir, I am Sasidharan. You told that you used that pumping technology like MTVCL and FDD and HRS, right? If you are not went with that technology, what will be your other choice to improve the ride comfort and handling?
See, all these are enhancements. Your ride and handling has to primarily come from your frame design, suspension design. But what happened when we started the vehicle some 3 years ago, we wanted to make, okay, this is a 5-door version of the 3-door, like that when you started. But as everything, fell into place, the car becoming better and better. Then at one point of time, we thought this is no more a 5-door version of the 3-door Thar. This is a completely different animal. This is the most luxurious, the most refined, the most powerful, the most iconic car that we want to create. We went into that kind of a thinking, that kind of thought process. So then when you want to offer that kind of ride and handling, obviously you want to use the best of technologies. இப்போ இதிலே கூட பார்த்தீங்க அப்படின்னா MTVCL and FDD we already use in Scorpio N, right? So obviously in the product development process, any product that is getting developed at the recent times will obviously use all the previous technologies wherever it is relevant, correct? Plus on top of that, we have introduced the hydraulic rebound stopper, which is first time in India we are doing because this car demanded the use of that. Especially in the speed breakers. Mr. Nandakumar will take a session on the vehicle dynamics. Probably he will also touch upon this topic. Almost it took 6 months to bring the vehicle, the speed breaker ride quality comparable to other vehicles or even better than other vehicles. We struggled a lot, and after that only we brought the hydraulic rebound stopper. So I would say the car would not have become a disaster without these technologies. It would be still fine. But how do you make the car to go from good to great? So அந்த லென்ஸ்ல நீங்க பார்க்கும்போது the advanced technologies வந்து you have to definitely use. So it is like you want to stop at 90 or you want to push the limits and you want to go to 99 and 100%. Correct. So that is the difference what we are talking. Let's say you can make the car to sell at 20 lakh very easily because the car has a lot of positive points. But if you want to make a car, like Thar, maybe a 25 lakh car, or in the future maybe 30 lakh. Today, the diesel variant, the two-wheel drive 80, 20.5 X showroom, but on road it becomes 25, 26 lakhs, right? Now that segment of customers always look for further refinement. They don't mind spending 2, 3 lakhs more, but they want that ride comfort. They want that, the high speed confidence. They want to feel that the car is highly refined, very premium, that they go to a 5-star hotel, and then in the lobby they get down from the car, people look at them and they say wow, right? That kind of respect they want to command, and when they're inside the car they want to feel very relaxed, they want to feel very safe, comfortable, correct? So how do you give that kind of experience? By using these kind of technologies.
Sir, sorry, sir. One last reasonable question I will ask and end this, sir.
Very quick.
Okay.
He has to go for another meeting.
I appreciate the spirit. Yeah.
Thank you.
Please tell me your name.
Yeah, please go ahead.
Myself, Jim Relton from SRM College of Engineering Technology, sir.
Yeah.
Sir, you talked about asymmetric LCA, sir. In media drives, Veluswamy say about the asymmetric LCA. He said about a new term he used. We use two bushes, one for lateral movement and one for the steering movement, sir. But you didn't speak about that. Can you say it shortly? What the use of the bushes?
Yeah, I did not want to go too deep because I just go back. In fact, I touched on the same topic only.
Yes, sir.
Yeah. So the bush which is in the front, this is called handling bush, right? So
yes,
this is the one which is taking the reaction for the lateral forces. So this has to be stiff. The bush which is at the rear, this is called the ride bush or comfort bush. This has to be soft. So when you have a asymmetric LCA, you have a very clear definition of what is your handling bush and what is your comfort bush. Because you imagine if the bush is exactly in the same line, then whatever the lateral force that is coming, only this bush will take, this bush will not take, correct?
Yes, sir.
If this bush is in the same line, the lateral force that is coming here is reacted by this push, correct? So that is the concept of asymmetric LCA. Of course, it is not possible to have it exactly same line because you have the four-wheel drive axle that is coming here. What we did, we slightly moved the axle rearward. We introduced a small angle in the drive shaft, and that is how we are able to get this geometry. Okay, but the ideal requirement is the front bush, I want it to be at the center line of the wheel so that it is reacting to all my lateral forces. The rear bush is doing only the job of the ride comfort. So in the proper, I would say, differentiation or demarcation of the function is possible in the asymmetric LCA. இப்போ நீங்க சிமெட்ரிக் எல்சி எடுத்தீங்கன்னா வந்து ரெண்டு புஷ்மே ரெண்டு வேலையும் பார்த்துக்கிட்டு இருக்கும். ஸோ இப்போ என்ன பண்ணணும் அப்படின்னா வந்து ரெண்டு புஷ்மே ஸ்டிஃப் ஆகிடும். ஸோ ரெண்டு புஷ்மே ஸ்டிஃப் ஆயிடுச்சு அப்படின்னா இப்போ வந்து இப்போ சிமெட்ரிக்கா இருக்கு. இப்போ ஒரு புஷ் நான் ஸ்டிஃபா வச்சுட்டு ஒரு புஷ் சாஃப்டா வச்சுட்டேன் அப்படின்னா இப்போ இங்க ஒரு ஃபோர்ஸ் ஆக்ட் ஆகுதுன்னா டயர் இப்படி திரும்பிடும், கரெக்டா?
எஸ் சார்.
ஏன்னா வந்து ஒரு ரியாக்ஷன் வந்து ஸ்டிஃப், இன்னொன்று வந்து சாஃப்ட். டயர் திரும்பி இப்போ டயர் இப்போ டாப் கீழ திரும்பிச்சுன்னா என்ன அர்த்தம்? யூ ஆர் லூசிங் த டைரக்ஷன் ஆஃப் த கார், கரெக்ட்? ஸோ to avoid that, what we will do, you will have to put both the bushes almost equal stiffness. But imagine the situation on the right side where one bush is very close to the wheel center. That bush can be stiff and that can take most of the load. The rear bush, which is a comfort bush, can be soft. So you are getting this additional degree of freedom to optimize the ride and handling. So this is how you get everything.
Yes, sir. Thank you, sir.
Okay, thank you so much. It was a great pleasure meeting you, meeting all of you. Learn as much as possible. Try to understand. Try to. Thank you so much. Okay, I wish every other session to be equally exciting. A lot of good sessions are coming. Crash is there, vehicle dynamics is there, and then practical sessions are there. Enjoy your day and all the best. And
Thank
hope
you,
to see
sir.
you somewhere
Thank you so much.
in MRV in the future. Thank you so much.
Yep. Thank you so much, Dr. Vikraman. Wonderful having you here with us, sir. Thank you, sir.
Thank you.
Yeah, so with this, we're going to take a very quick 5 minutes break, just a bio break. If at all anybody wants to use washroom, please remain seated if you don't want to, because next we're going to have the session with Mr. Veluswamy, the president, which most of you would be knowing. It starts at exactly 11:20:25. Maybe by 11:25 max. So if anybody want to use the washroom only, please kindly go back and come out. People who are okay, you're welcome to be seated here. Thank you.